Hello and welcome to my channel. My name is Adriaan and today we are going to build a one-cylinder pressure ignition engine. Let's go. So in front of you, you see the finished product. You can see the one cylinder in the middle with the ambient objects in the left and the right, and our inlet manifold, inlet port valves, exhaust port and exhaust manifold. So to get started, we're going to start off with a blank canvas, and we are going to drag all the components, all the objects from the library that we need. And then after that, we can just go and connect them all. You will see as soon as I connect a duct to my cylinder, a valve will be automatically created. So you need to leave some room between the duct and the cylinder so that there is room for the valve to appear. I'm also going to change my injector to total air fuel ratio so that I can connect it with my cylinder. All right, so now everything is on the canvas. I'm just gonna quickly make it a bit more neater, make everything in line. Once you're happy with the layout, the only thing left to do before we start editing some of the properties of these blocks are to rename them to make sure that we can distinguish between the ducts and that their names make sense. So everything's been renamed with descriptive names. So now we're gonna go and we're gonna start changing the geometry input of these objects first. So to do that, we just click on the object, and to the right in the properties window, the geometry window appears with all the diameters and lengths that is required for you to input. Some default values has been given, but we are going to change that. When we look at our ambient objects, we can see the initial conditions has been set by default as to default fluid state. And we have a look at what that is. It is a pressure of 1 bar and temperature of 300 Kelvin, which I'm happy with. I'm going to leave that as is. So now we can move on to the cylinder and change its geometry, which is the bore, the stroke, clearance height, etc. You will see I put a value for compression ratio as CR, which is a variable. And as soon as I press enter, Ricardo WAVE will prompt me to add the variable to our parameters list and needs a value for it. So we're going to give that value, leave it at 10 for our compression ratio, and we're just going to say add. We're also going to create some variables for our boundary conditions. This is the temperatures for the piston liner head and valves at the start of our simulation. And we're also going to put in variables for these values. And for our head, intake valve and exhaust valve, we're going to take the same temperature. So we're going to just put in temperature head for both these valve values. Next is our valve. So we've got our intake valve. Valve type is left, we're going to keep. Our reference diameter is going to be 35. And then we need to add a lift profile. So we click on the green plus button, we edit it, and we are going to go with a tag. And we are going to use the intake valve lift for the spark ignition tutorial, which is saved in Ricardo WAVE. So we can just allocate that as our valve lift profile. If you click on the button, you will see this is shown. This is the valve lift profile that's been saved under this tag, and we're happy to use that. Our cycle anchor is going to be 330 degree, and we are going to go with a lift multiplier of 1.414. The rest of the values we're going to keep as is. And then also we need to go and just have a look at the flow coefficient profile that's already been populated for us. So if we go have a look, you will see it is a typical valve flow coefficient profile. And if we have a look, there is the value. So if you want to change this, this is where you're going to do it. But for this tutorial, we're going to keep it as is. Going to move on to the exhaust valve. Reference diameter is 28 millimeters. And then we need to add a lift profile for the exhaust valve. And again, we are going to use a tag, and we are going to go for exhaust valve lift for spark ignition tutorial. So that is again a predefined lift profile for the valve. For the exhaust valve, our cycle anchor will be at 105 degrees. And the rest we are going to leave the same. Next up is our cylinder. So we've already populated the majority of the cylinder data. Now we're going to move on to the submodel. Now here in the submodels, we are going to specifically look at our combustion submodel, which we need to add. So we're going to press the green plus button, and here it lists all the different combustion models: diesel weep combustion, multi-weep combustion, profile combustion, and then our SI weep combustion, which we've used previously. And this is what's going to distinguish your model from spark ignition or compression ignition. So we are going to go with the diesel weep combustion today because we want to simulate one cylinder diesel engine. So we're going to double click on the diesel weep combustion model, and then we're going to edit it. So these are the properties required for the diesel weep combustion. The reference speed we are going to change to 4000. We're going to leave the profile control to terminate after all the fuel has been burned. So our burn fraction will be 1. If it's less than 1, it means not all the fuel has been burned. But for this tutorial, we are going to leave it as 1. We're also going to uncheck our ignition delay, and that gives us the option to specify the start of combustion, which is a value in degrees after top dead center. So we're going to use a variable. We're going to put a variable in here, SOC, which stands for start of combustion, and we're going to put a value in of -1. -1 will mean that combustion starts at 1 degree before top dead center. Our pre-mixed fuel fraction will be 0.02. That means that 2% of the combustion is pre-mixed, and the rest will then be diffusion. The only thing left now is our injector. So at the start of the video, I've selected the injector type as total fuel air ratio. And again, because of that, it asks us for the fuel air ratio. So we're just gonna give another variable f_a, which is our fuel air ratio. When we click enter again, we're going to need to specify what that ratio is, and we're going to set it at 0.05. We also need to specify the start of injection. I'm going to put another variable in, start of injection, and we are going to put that at -7.6. Again, that just indicates that it is 7.6 degrees before top dead center that injection will start. Mixture temperature will be increased to 350 Kelvin. Our nozzle diameter will be 0.1, and we're gonna specify a spray spread angle of 40 degrees. Default fuel has been automatically selected. If you're unsure what that means, you can just go and edit it. This basically means that 100% of the fuel injected into the cylinder will be comprising of liquid fuel. Now we just need to specify injection rate and injection pressure. You can see those are empty, so we need to click the green plus button to create new ones. And then we're going to edit their properties. For the injection rate profile, it's a table. We need to edit that. So we're going to press the edit injection rate. And here we are going to make a few changes. We're going to add another variable. And rather than saying 20 degrees is the full duration of our injection rate, we are just going to put in a variable injection duration, and we're going to specify that as 21.1 degrees. So now anytime you want to change your injection duration, you don't need to come to this table to change it. You can just change it in the variables list and it will update accordingly. Next is our injection pressure. Again, it's a table that we need to populate. So for this one here, we're going to say at 0 crank angle degrees, it's going to be 300 bar. And then again, for a given duration, which we're going to specify in our variables list, it will be 500 bar. So it will be 500 bar injection pressure, the same duration as the injection duration. So everything has been updated, all our geometry and input values for every block's property. So now all our properties have been updated, all the geometry values have been entered. If you want to see the list of your variables, you go to the session tree and you will see there's a folder case sets with little table icon with the name cases. So you just need to click on that, and then this little table will pop up and we will see all the cases listed here. Now looking at that, I can already see that I have forgotten to specify the engine speed. So we can go back to the model. We need to add our engine block, which I have forgotten to add. Engine shape is inline. It is spray guided. The rest of that values can stay the same. And here at engine speed, we are just going to specify a speed value. Our engine friction model will just be the default friction model and the default scavenging model. And then our engine blocks property has been updated as well. Once we are ready and we are happy with everything that we've put into a variable list, we can go and press the running man to start the solver. Once the solver is finished, we can head on over to WavePost to have a look at the results. Now if we double click on the engine block, we can get a nice summary of all the information that's been calculated. Get a nice brake thermal efficiency of 34.97, which is essentially 35%. Brake specific fuel consumption of 0.238 kilograms per kilowatt per hour. Brake power is 4.6 kilowatts. And we can also have a look at our brake torque, which is 22.11 Newton meters. And that's it. That is how you go and model a 1-cylinder compression ignition engine. If you've got any questions with regards to this tutorial, please do not hesitate to put them in the comments section below. I'm also on LinkedIn and Twitter. My Twitter handle is @ASVia90, where you can connect with me and ask as many questions as you like, and hopefully I'll be able to answer them. Thank you very much for watching, and I will see you in the next video. Bye.